The second topic in module 3 is sensors and interfacing. Okay, so what is meant by sensor? Sensor is a device which sends the quantity, right? So sensor provides us with a means of generating signals that can be used as inputs to electronic circuits. So one of the best example is your thermometer, which measures the temperature, right? So the first topic under this subdivision is instrumentation and control system. So what is meant by an instrumentation and control system? So this figure 1 gives the block diagram of your instrumentation system, and the second figure gives the block diagram of your control system. So instrumentation system is nothing but an open loop system, and your control system is a diagram which has a feedback system. Okay, closed loop system. Open loop is for instrumentation. Control, you are going to control something, so it is a closed loop system. So the instrumentation system basically consists of the input is going to be your sensor, which sends the physical quantity, for example temperature, which gives output of the sensor is going to be an electrical signal which is given to the signal conditioning circuit, which makes the signal into a suitable form, which is used for the next stage. Next stage is going to be a signal processing, display and recording. For example, in the case of ECG or EEG, this is an example for your instrumentation. You're going to record the data and you're going to display your output. Okay, so this is called, you're just going to record the data and it is used for displaying the values. So these are the example of your instrumentation system. So this is the output data will be in the suitable range. Whereas in the case of control system, what is happening, you are going to control the parameter. For example, your geyser or your air condition system or your heater, all these are your control system, right? So it basically consists of a negative feedback. So the input basically consists of the input and the comparator, which compares the both the signal. So what should be the basic criteria here? The error signal which is induced should be 0. Only then you will be getting the proper output. So you will basically you will be having a comparator. This will be a control device, and with the sensor which senses the signal and it gives back to your comparator. So you will be getting the output which is a controlled signal. So the input will be normally taken as your potentiometer across the stable DC source, and your control device may be a DC motor or linear actuator, heater, etc. So this is your general block diagram of your control system. Okay, so your next topic you have is your transducer. So what is meant by a transducer? Transducer is generally it is a device which converts one energy form to another, right? So devices that converts energy in a form of sound, light, heat, etc. into an equivalent electrical signal is called as a transducer. So sensor is one of the subset of your transducer. Okay, so some of the example of your transducer are, for example, see here, loudspeaker and your microphone. Loudspeaker, which converts your low frequency electric current into an audible sound. So it is used as an output transducer, whereas your microphone is used as an input transducer. Sound pressure variations are converted into a voltage or current. So these are some of the three examples for sound, temperature and angular position. Sound, it is microphone and loudspeaker. This is your input transducer, output transducer. Temperature, input transducer will be thermocouple and output transducer will be your heating element. Whereas in the case of angular position, both will be a rotary potentiometer. Okay. So the next topic is going to be a sensor. Sensor is a special kind of transducer. It is a subset of your transducer which is used to generate an input signal to a measurement, instrumentation or control system. The signal produced will be equal to the electrical analogy of physical quantities such as distance, velocity, acceleration, temperature, pressure, etc. Your sensor can be divided into two types, active and passive. Active means which directly generates a current or voltage output, whereas passive means it will not generate directly, but it requires a source of current or voltage converter voltage, and it modifies it in some way. And again, it can be classified into two types based on whether your current and voltage is analog or digital. If it is varying, time varying, then it is analog. If it is 0 and 1, it is digital in nature. So in the next video, we will see the different types of actuators.